On this 2019 to 2024 Ram 1500 Classic with the 5.7 Hemi P0430 is a Bank 2 catalyst efficiency code. In plain terms, the PCM may be seeing the rear oxygen sensor activity getting too close to the front oxygen sensor activity, which can make it look like the catalyst is not storing oxygen the way it should. The driver may only notice the MIL. Before calling the converter bad, keep the broad fault areas in mind: an exhaust leak, an engine mechanical condition, an aging or fouled oxygen sensor, or the catalytic converter itself. Treat this as a performance and plausibility diagnosis, not just a parts call. The catalyst monitor uses both the upstream and downstream O2 sensor signals to judge catalyst aging. As a catalyst loses oxygen storage capacity, the downstream sensor state of change increases and starts to look more like the upstream sensor. The PCM compares the downstream to upstream ratio over a calibrated period of time. Typically, a properly working catalyst is approximately 0.2/1 on that ratio, with the downstream O2 sensor line measuring approximately 20% of the upstream O2 sensor line length. If that ratio becomes greater than a calibrated threshold, approximately 0.6/1, the PCM considers the catalyst failing. The upstream O2 slow response check is also part of the logic, and that decision is made before the catalyst decision to help prevent a false catalyst failure. The monitor runs when there are no active O2 sensor circuit faults. There are several catalyst efficiency windows, but the best opportunity to get the monitor to run is with engine temperature above 70 degrees C, 158 degrees F, engine speed between approximately 1,000 RPM and 3,000 RPM, and vehicle speed between 20 mph and 85 mph under moderate engine load. Use those as the operating conditions when you try to reproduce the fault. Start with the basic system checks before going deeper. With the scan tool, read DTCs in all ECUs and record them. Save the vehicle scan report and the related recorded data. Then erase all DTCs, turn the ignition off for a minimum of 0 seconds, turn the ignition back on, and operate the vehicle under the conditions that set the code. Use the captured conditions and the monitor gates to guide that road test. After that, read DTCs again. If P0430 does not return, handle it as an intermittent condition. If it does return, continue with the next check. Next, look back at the recorded DTCs. If there are upstream or downstream O2 sensor signal or heater codes present, diagnose those O2 sensor codes before continuing with the P0430 path. That matters because the catalyst decision depends on the front and rear O2 sensor signals being believable. If those O2 sensor codes are not present, move on to the catalyst and exhaust checks. Now visually inspect the catalytic converter inlet and outlet. Look for physical damage like dents or holes, signs the converter is leaking, signs it is internally broken, or severe discoloration from overheating. If any of those problems are found, replace the catalytic converter and repair the condition that may have caused the failure. Then verify the repair and confirm the code stays gone. If none of those problems are found, keep testing before condemning the converter. Next, check the exhaust system for leaks. Pay close attention to leaks ahead of the catalytic converter because they can skew the upstream O2 sensor behavior and fail the catalyst monitor. Depending on location, even a very small leak can be enough to cause trouble. If leaks are found, repair or replace the leaking exhaust parts as necessary, then verify the repair and confirm the code stays gone. If no exhaust leaks are found, continue. After the exhaust check, look for an engine mechanical issue. Check the exhaust for excessive smoke from an internal engine problem, and verify the upstream O2 sensor is not fouled because of a mechanical engine failure. Oil, coolant, or excessive fuel can contaminate that upstream sensor, and that sensor sits directly in the exhaust output path before it has any protection from the catalyst. If an engine mechanical condition is present, repair it as necessary. Then verify the repair and confirm the code stays gone. If it is not present, Continue. Now review the vehicle repair history. Specifically, check whether the downstream O2 sensor was replaced recently without replacing the upstream O2 sensor. A new downstream sensor paired with an aging upstream sensor can sometimes cause the catalyst monitor to fail. If that history is present, replace the front O2 sensor as necessary, then verify the repair and confirm the code stays gone. If that history is not present, move to the final repair direction. If P0430 returned, there are no O2 signal or heater codes driving the result. The converter inspection did not explain it. The exhaust is not leaking. There is no engine mechanical condition, and the sensor repair history does not point to a mismatched front and rear O2 sensor situation. The remaining repair direction is to replace the catalytic converter. After replacement, verify the repair and confirm the code stays gone. The key is to prove the monitor result before replacing the converter. Make the O2 sensor data credible, rule out leaks and engine contamination, check the repair history, and only then follow the converter repair path. For more diagnostic training, visit stepdiagnostics.com.